The first question is the logical expression y is equal to a plus a bar b is equivalent to, and this is a question from TRP 2012. And now y is equal to a plus a bar b. So we take a into 1 plus b because this 1 plus b equivalent to 1. So multiplying this a with this 1, we cannot change the logic expression. So we multiply this a with 1 plus b plus a bar b. So now become this a 1 plus a b plus a bar b. So now consider this is equal to a again, and plus you can take b outside from this two term, and this become a plus a bar, and this value a plus a bar become 1. So we will get a plus b. So the equivalent expression for this a plus a bar b is equal to a plus b. So here the answer is D. Next question, the min terms corresponding to decimal number 15 is, and the decimal number 15, the equivalent binary is 1 1 1 1. So if a b c d that used to represent the binary value means this a, that is represent as a. If 0 means that is represented as a bar. So now this is 1 means we represent this one as a, mean this one as b, this one as c, this one as d. So the min term corresponding to decimal number 15 is a, b, c, d. So here the answer is A. Next question, the maximum count for which a 6-bit binary word can represent is. So the maximum count here is 2 power 6, that means 64. But the word can represent using this 6-bit binary is 0 to 63. So the maximum representation we can represent the number 63. So here the answer is C. Next question, the hexadecimal representation of 6578 is, and here 8 means we use 3-bit to represent each number. So 7 means we can represent the 7 as 111 and 5 as 101 and 6 as 110. So now we represent this in hexadecimal. For that we group 4 bits, and this 1 means remaining 3 zeros. So first one is 1, this one's 10, and in hexadecimal that is equivalent to A, and this is 15, that is equivalent to F in hexadecimal. So here the hexadecimal representation of this number is equal to 1AF. So here the answer is B. Next question, the output Qn of a JK flip-flop is 0. It changes to 1 when a clock pulse is applied. The input J and Kn are respectively. And when the Qn change from 0 to 1, the J must take the value 1. But the K value, it may be 0 or 1. So it can take either value. So it can represent it as X. But the J value must take 1. So here the answer is J value is 1 and K value is X. So here the answer is A. Next question, how many flip-flops are required to build a binary counter circuit to count from 0 to 1023? So we have to count 0 to 1023. So total count is 1024. This can be represented as 2 power n. From that we can find n is equal to 10. So here 10 flip-flops required to build a binary counter that used to count 0 to 1023 is 10. So the answer is C. Next question, the digital multiplexer is basically a combinational logic circuit to perform the operation of and OR. So first it perform AND operation, then OR. So here the answer is C. Next question, how many 3 to 8 line decoder with enable output are needed to construct a 6 to 64 line decoder without using any other logic gates? So here we find the record decoder using that formula, that means the 64, we can write that 64 as 8 cross 8. So this 8 cross 8, we take 8. Another one method, that is 64 divided by 8, that gives 8, and also this output, that is 8 divided by 8, that will give 1. So if you are adding this 8 plus 1, that is the decoder to realize the 6 to 64 decoder. So here the answer is C. The number of comparator in a parallel conversion type 8-bit 8 to D converter is, the number of comparator we can find using the formula 2 power n minus 1, and here n is 8-bit. So we have 2 power 8 minus 1. So here the answer is 256 minus 1, that is equal to 255. So here the answer C. Next question. In standard TTL, totem pole stage refer to output buffer. So here the answer is C. Next question. For the logic circuit shown in the figure, the output Y is given by, and this is Y. So considering this Y, we will get A plus B here, and we will get A plus B into C the whole bar here, and here DE, and this becomes DE bar here. So if you are giving the input this 2 inversion, we will get the exact term of this. Without this inversion, we will get a output here. So if we give the inverted input this NAND gate, we will get the output as equivalent to the without inversion expression. So now this Y is equal to A plus B into C plus DE. So this is the logic expression, because we get here the same expression we get like this, A plus B into C the whole bar into DE bar the whole bar. So we solving this, we will get A plus bar get cancelled, so A plus B C, and this and become more here, and DE bar the whole bar, this become DE. So here the answer is A plus B into C plus DE. So here the answer is A plus B into C plus DE. B is the answer. And next question, which of the following Boolean expression is incorrect? And this is a question from TRB 2017. And by seeing the answer itself, we can find the wrong one, because this A plus AB, that means if you take A out, we will get A plus 1 plus B, and this become 1, we will get answer equivalent to A, but they are giving the answer is B. So the wrong one here is B. Next question, which of the following flip-flop used as latch? And all flip-flops can be used as latch, but commonly used latch is D flip-flop. So here we can mention D flip-flop as a result. So answer is A. Construct 16 cross 1 mux using 2 cross 1 mux. How many 2 cross 1 mux are required to construct? So first 16 cross 1 means for 2 input it requires 8, and this one is 8 single output. So 1 to 8 we use first, because 8 cross 2 is equal to 16. So this 16 input can be used. This 16 input can be represented using 8 2 cross 1 mux. So first stage it requires 8. Then next stage the 8 output, we get the 8 output here. So the next stage we record 4 2 cross 1 mux to provide the answer to next stage. So first we get 4, next we get 4, first we get 8, next we get 4. So 4 mux means it will provide 4 output. So it requires 2 mux. So in this stage we record 2 mux. Again this 2 mux given to 1 mux to get a final result. So final stage we record 1 mux, 2 cross 1 mux. So total 12, 14, 15. So totally 15 2 cross 1 mux are required. So here the answer is A. Next question, simplify the expression A plus B the bar plus A bar plus AB the whole bar. So without taking the bar, we consider this term and this term. So from that we can find x plus x bar, that is equal to 1. So simplify this. we will get 1 plus a bar the whole bar, and anything added with 1 means the result is 1. So now this 1 plus a bar become 1, always 1. So result is 1 bar. So the bar of 1 is 0. So always the expression, the output for this expression is 0. So here the answer is B.